guys, in this video we're going to be looking at dimensional analysis. And dimensional analysis is what we call unit conversion. So converting from one unit to another without changing the magnitude of the value, just changing the units that we're expressing that value in. We're going to be looking at metric units, we're going to be looking at English units, we're going to be looking at converting between them and converting within metric systems and English systems of units. With dimensional analysis, unit conversion, we are going to use what's called a conversion factor to convert between units. With a unit converter, we consider this to be have a value equal to 1. And the reason this has a value equal to 1 is because it's basically an equality. So for instance, if we took 1 dozen, if we say something is 1 dozen, we know that equates to 12. 1 dozen is equal to 12. 1 dozen eggs is equal to 12 eggs. 1 dozen donuts is equal to 12 donuts. So we would say that 1 dozen is equivalent to 12. Because this is an equality, we can use this as a unit converter. So to convert from an equality, to a unit converter or a conversion factor, we just make it a ratio. So 1 dozen over 12, or 12 over 1 dozen. And because they are equivalent, they are both going to be equal to 1. And hopefully we remember from math that anytime we multiply or divide by 1, we are not going to change that value. So we can multiply and divide by 1 however much we would like, and multiplying or dividing by a unit converter or a conversion factor is the same as multiplying or dividing by 1. So with our steps for unit conversion or dimensional analysis, we're going to look at simple first. We're going to determine the starting and desired units. That's our first step. You always want to go ahead and determine what your starting units are, what your desired units are. And then you're going to come up with a conversion factor that contains both units if we have a simple problem. If we have a more complex dimensional analysis problem, then we're probably going to have to come up with several. So if we have a complex unit conversion, we may need 2 or more conversion factors. And at that point, it becomes more like a puzzle trying to figure out how you can go from one unit to the other. After we've determined what conversion factors we need, we're going to use the initial value and a starting conversion factor to convert your units. Keep adding conversion factors until the desired unit is found. Okay, so then we multiply, divide the whole thing out. In general, what this would look like is we'd have our given unit, so whatever our starting unit is, then we'd multiply it by our conversion factor. The desired unit would be on the same side as our given unit, the same side of our ratio as the given unit, and then the given unit in our unit conversion would be on the opposite side of the ratio, so they can cancel out. And then our desired unit, make sure that it is on the right side of the ratio. You could also see something like this where you have 1 over the given unit. And in this case, you want to make sure your given unit cancels out, so have it on the opposite side of the ratio. Like so. Okay. These are how we are going to convert between English, English metric, and then metric. Okay, so these are a listing of several different conversion factors that we can use. It's pretty easy. Let's try a metric conversion, for instance. So if we want to go from, it's pretty easy. Let's try a metric conversion, 9474 millimeters. And we want to go into centimeters. So we look, this is a metric. Here is centi, here is milli. So we would say, generally, when we're doing metric, especially when you're starting out, you want to go back to your base unit. So there are 1,000 millimeters, 1 meter, or 0.001 meters per 1 millimeter, depending on how you look at this. Then with our centimeters, there's 100 centimeters per 1 meter, or 0.01 meters is equal to 1 centimeter. So the way this is written is how many of the base unit is in one of the prefixed unit. And then we want to make sure that we go from millimeters to meters and then to centimeters, like so. So we have 9474 millimeters. For every 1,000 millimeters, we have 1 meter. And then for every 1 meter, we have 100 centimeters. I've placed it so that I cancel out the units that I want to get rid of, millimeters and meters, and I'm left with the unit that I want, centimeters. And we multiply this across, we get 947.4 centimeters. Let's try another conversion. Let's go from 32 feet per second into meters per minute. So we're basically going to go from feet to meters, seconds to minutes. So we can start wherever we would like. There are 60 seconds in 1 minute. So that'll cancel out my seconds, leave me with minutes on the correct side of the ratio. And then we want to go into feet. And then we want to go from feet into meters. So if we look up here, we can see that we have 2.54 centimeters per inch. That's a pretty good one to commit to memory. So we're going to use that. 2.54 centimeters in 1 inch. We are currently in feet, so we need to go from feet to inches. And then we can go from inches into centimeters. And then we go from centimeters into meters. So there are 12 inches per 1 foot. That'll cancel out my feet. Then we have, for every 1 inch, 2.54 centimeters, canceling out our inches. And then there are 100 centimeters per 1 meter, leaving us with meters per minute. And when we do this math, we get 585.216 meters per minute. We do need to think about sig figs here. There are exact unit converters, and then there are inexact unit converters. Anything within the metric system is considered exact, so we don't really need to consider that when we're thinking about significant figures. But many of our metric English conversions are inexact. However, this one right here, the one we're just looking at, is an exact conversion. So we don't have to consider it in the calculation of the significant figures. The only thing we need to look at is our initial value, because all the rest of these are exact values. So our starting value had 2 sig figs. Our ending value needs to also have 2 significant figures. So when we round this out, we get 590 meters per minute. So one of the big things having to be taken into account when doing these unit conversions is how many significant figures you're going to need at the end. If you have exact conversion factors, so conversion factors that include exact numbers, you don't need to consider them when determining your calculation rules for your significant figures. The unit conversions themselves are going to be multiplication division rules. So remember, when you multiply 2 numbers together or divide 2 numbers together, you're going to take the number that has the least number of significant figures, and that will determine the number of significant figures in your calculated value. This is the only one that is an inexact number, that 32. So that's the one that we took the number of significant figures, had 2. So our answer will also have 2. Within our metric system, all of them are considered exact conversions. So we're going to do the same number of significant figures as your initial value, the initial value that you are converting the units for. That will determine how many significant figures your end calculated value has. I want to do one more type of unit conversion, and that's using density as a conversion factor. So remember, the density is mass over volume, right? And because it is a ratio, we can use it as a conversion factor. So if we want to go from grams into milliliters of a specific substance, if we know that substance's density, we can use it to go between grams and milliliters or milliliters and grams. Keep in mind, density is generally going to be given in grams per centimeters cubed or grams per milliliter. So another thing we can do is go from grams into centimeters cubed. One of the densities that you should know and commit to memory is the density of water, which is going to be equal to 1.0 gram per milliliter or 1.0 gram per centimeter cubed. So let's try that. We want to know, what is the mass in grams of 5.80 gallons of water? So we are currently in gallons, right? And we want to get to grams. If we want to go from a volume unit into a mass unit, We will almost always, as long as we're talking about a pure substance, if we are talking about a pure substance, we're going to use density to go from volume to mass and vice versa. So, grams is a metric unit, gallons is an English unit, so we need to go up here and look at what we have. Here we go. Here are gallons right here. There are 264.2 gallons per 1 meter cubed. 264.2 gallons in 1 meter cubed. So we can take our 5.80 gallons, 264.2 gallons per 1 meter cubed. And now we need to go from meters cubed into a unit that we can use to calculate our mass. We have water, so remember it's 1.0 grams per centimeters cubed. So we need to go from meters cubed into centimeters cubed. So there are 100 centimeters per 1 meter. But when we do this conversion, going from meters to centimeters, this is only going to get rid of one of those meters, so we're going to have to do this conversion 3 times to get rid of all 3 meters and get centimeters cubed. And then when we do that, we get 21,982 centimeters cubed. And then we're going to take into account our density, 1.0 grams per centimeter cubed. Canceling out our centimeters cubed, leaving us with grams, 21,982 grams. And then, of course, this is inexact. This is inexact. This is inexact. The one with the lowest number of significant figures, which is our 1.0 at 2 sig figs, will determine our number. So when we round this out, we get 22,000 grams. Okay, that's everything for unit conversions and dimensional analysis. Talk to you guys in the next one.